Hello to everyone, and thank you for watching my video. I've already done this video in an Italian and Catalan version, and in the next weeks I will also make a version in Spanish. If you might be interested in any of those, you can go and look for them on my channel. Before starting the video, I wanted to excuse myself for any silly English mistakes that I might make, because my English is not perfect. As you all know, this video is going to talk about the Bitcoin. I think it's a really fascinating thing, and that everyone should at least understand it a little bit. So let's start. Before starting this video, I wanted to read this sentence that was said by an economist, because I think it's really interesting and explains a little bit why I am doing this video. So, he said that Bitcoin technology seems to promise major changes in our financial systems, but few can say exactly how or why. Well, we are here to discover this. Let's start with the characteristics of Bitcoin, the most general ones, but they will help us to go little by little and return more in the specific. So, Bitcoin is a digital cash. This means that it is only digital, it's not physical, it's only in the internet, in the computers. And it is not managed, and it isn't issued by any bank or country. Instead, it is issued and managed by a software. This software is free, and anyone can download it. The software that makes Bitcoin work is not on a server, and instead it is decentralized. This means that it is distributed in the computers of all the users of Bitcoin. Bitcoin is peer-to-peer. This means that when you do a transaction, the money don't go through a central authority, like in a centralized system, but instead the money goes directly from a person to another, from one computer to another. All the transactions are kept on a digital distributed ledger, and this ledger is called blockchain. Everything started the 31st of October of 2008. So, just a few days ago, it was the 10th anniversary of Bitcoin. That day, an unknown person called Satoshi Nakamoto sent an email to a mailing list of cryptography, where he said that he was working on a new electronic cash system that was fully peer-to-peer with no risk of a trusted third party. What is a trusted third party? Well, it's a bank. Why third party? Well, because they enable us to make transactions by staying in the middle. And why trusted? Well, because we trust them that they make the transactions correctly. In the main properties of this new cash, Satoshi Nakamoto said that he could prevent double spending. I don't know if you've ever noticed, but in the internet, everything is doubleable. If you want to send an image to someone, you won't send him the image. You will send him a copy of the image. Just try to imagine a cache that can be doubled all the time. It wouldn't have any value. And at that time, double spending was considered impossible to solve. For this reason, really few people believed Satoshi Nakamoto. However, he continued to work on Bitcoin, and finally, in the 3rd of January of 2009, he released the source code of Bitcoin. For the ones that don't know it, the source code of a software is the first version of it. Now I'll tell you some interesting information about Satoshi Nakamoto. First of all, still today in 2018, we don't know his identity. We don't know if he was a man, a woman, or maybe even a group. This is mainly because he disappeared in 2010. It wasn't a sudden thing, but it was a thing that came from a long time. At first, he told a lot, by email, obviously. But then, all the time, less and less, until he only talked with some programmers, friends of him. One of those friends was called Gavin Anderson. One day, Sia asked Gavin to go to an interview about Bitcoin. Gavin told Satoshi, And from that day on, Satoshi never talked again. So he completely disappeared. Another interesting fact about Satoshi Nakamoto is that he owes about approximately 1 million of bitcoins, and he has never spent one. In this presentation I will use the word Bitcoin with two different meanings. Bitcoin with B uppercase means the software in general, everything together. Instead, Bitcoin with B lowercase means it is referred to the unit of currency, just like saying an euro or a dollar. Let's talk now about the software. It has to do two main things. First of all is to manage transactions, and then you also have to create new bitcoins. A really important thing about this software is that this is open source. This means that if more than 50% of the users of Bitcoin allow it, a programmer can modify the software of Bitcoin and trying to improve it. By this way, it allows Bitcoin to grow and improve at a really fast pace. Also, it is open source. It means that anyone can copy, modify, or change the source code of Bitcoin. This allows the creation of many other cryptocurrencies that try to improve Bitcoin. We said before that Bitcoin was peer-to-peer, that Bitcoin is peer-to-peer. But where did this come from? Well, it comes from BitTorrent. I don't know if you have ever heard of it. BitTorrent is a program of file sharing. A program of file sharing is basically a program where you can upload and download files by sharing it with other people in the network. Usually programs of file sharing were server-based. This means that somewhere place in the world there was a server and people could upload and download files from that server. What happened? Well, usually most of these files were music or films or series or things like this, and they didn't pay for the copyright. So the authorities searched for these servers, found them, and stopped them. So when they have stopped them, all the computers that were uploading and downloading files from that server were left completely out. They couldn't share their files anymore. To avoid this problem, the creator of BitTorrent made a file sharing that was peer-to-peer. Well, how did it work? Well, everyone had some files on their computers, and all the others could copy the files of all the computers. So, for example, if I had one film, someone else could copy it, and then we would be two computers that had that film. And me, myself, I could copy some files from other computers. And in this case, if a computer, for some reason, was shut down, all the others could still go on sharing their files. The files that that computer that was shut down had, probably they weren't lost forever, because all the other computers could probably had already copied them, and they could still go on sharing them with no need of that first computer. Bitcoin works in a similar way, but with only main difference is that in Bitcoin all the computers have the same file, the software of Bitcoin. This is really important because if someone would try to stop Bitcoin or BitTorrent, they would have to shut down thousands of computers all around the world. And this is nearly impossible. Okay, so we already said that Bitcoin software is free and anyone can download it. All the people that have downloaded it are called nodes. All the people and all the nodes form a network where the software of Bitcoin is distributed. One of the main parts of the Bitcoin software is what I said before, the ledger, where the transactions are kept. This ledger is really special because it contains all the transactions of the history of Bitcoin. All of them. Also, it's really important because it is unchangeable. This means that it's hardly impossible, it is nearly impossible to change any transaction that happened. And what's more, it is public. This means that anyone, anywhere, can access to it and can see all the transactions. And this ledger is called blockchain. And the blockchain transactions aren't written one after one, like if it was a list. No, they're grouped into blocks. Blocks of about 2,000 transactions. So block is a set of transactions. This is important that you understand it. A new block is created every about 10 minutes, approximately. As I said before, every 10 minutes, a new block is created. And it's just like if a ring was added to a chain. A chain made up of blocks. Blockchain. So just to make you understand where does the name come from. But who creates and how are creating new blocks? Well, the ones that create new blocks are called miners. They are like some special nodes. Miners, what do? Well, they do mainly three things. They can see all the transactions that have been submitted, but that haven't entered the blockchain yet. Then, when they can see all these transactions, they have to choose some of them. Then, when they have chosen some of them, they have to validate them. What does this mean, validate? Well, it's a bit the work that banks do. So, they have to see if your password is correct, and also if you got the bitcoins that you want to send. When they have chosen some transactions and they have validated them, they put them into a block. But then, when all the miners have prepared the block, we could say, how do they choose which one of them will get its block and will create it then? So he will add his block to the blockchain. Well, to choose which one of them would do this, they do a calculus race. And you will ask yourself, but why do they do this? What do they gain? Well, because the winner of this race, of this math race, will create his block, so he will add its block to the blockchain and will receive as a reward new bitcoins. And this is how new bitcoins are issued. And it's the only way to create them. So I just thought of some illegal ways to create, for example, dollars or euros. So, for example, you can see in some things that some thieves make a machine that prints money at home, or that someone robs a bank or the place where money is created. And as you will understand later on, there can't even be false bitcoins. It's just impossible. In this race, all the nodes can participate, but the calculus is so difficult that you need a very powerful computer to win the race. So at the end, most of the nodes just stopped participating because they never won, and the only nodes that were left were the miners. But what is math race about? What is this calculus that they have to do? Basically, what they have to do is functions. A function, yes, where you give it an input and it gives you an output. For example, a function would be 2x is equal y, where x is the input and y is the output. If the input is 3, the output will be 6. It's interesting to see that if I tell you that the output is 6, the input, everyone can understand it's 3. The function that miners do, it's a little bit different because it's a cryptographic function. It has two main characteristics. First of all, it is irreversible. A cryptographic function is irreversible. This means that from one input you can get an output. But if I tell you the output, you won't be able to understand the input. So, for example, to tell you a practical example, it's a little bit like DNA and your fingerprint. If I give you a DNA, you can get a fingerprint. But from a fingerprint, you cannot find from which DNA it comes from. The other characteristic of a cryptographic function is that the output has a fixed length. This means that an output has always 256 bits. Remember, we are talking about computers, so it's always bits, ones and zeros. So in these functions, the output is always 256 bits. Instead, the input can have an arbitrary length, can be any length. And because it's computers and it's ones and zeros, the input can be text or even photos or videos. For the computers, it's just the same. Everything is just ones and zeros. But however, no matter how long is the input, the output will be always 256 bits. And in this case, in the case of Bitcoin, in the case of this cryptographic function, 256 bits can be transformed, we could say, into 64 numbers and letters. For example, these ones. This could be an output of a cryptographic function. And these like strings of numbers and letters are called hash. These functions are also called hash functions. Now I'll tell you some examples of a hash function to make you understand it a little bit better. I went to a website, you can see it here below, and I put into an input hello world. And as you can see here, I got this output. Then I did the same, but by erasing the space. And as you can see, the output was completely different. This is because no matter how long the input is, even if you change only 1 0 or even you change only 1 bit, the output will change completely. This makes it literally impossible to know what the output will be before calculating it. You will be asking yourself, but how do the miners use the hash function? How does it work? What do they get as an input, and how do they use the output? Well, they get into the input two things mainly. First of all, they get all the transactions of the block. So all the transactions that they have chosen and validated, they put it into the input. And then also they put into the input a little, we could say, information from the previous block. This way we could say that they chain themselves to the previous block. When they've got this, they have to try that the output will have a specific characteristic. For example, that the output should have, let's say, 18 zeros at the beginning. And how do they do this? Well, in the input they also put the nonce. The word nonce comes from the two words no sense, without meaning. And the nonce is a number, a casual number, that they put at the end of the input. So they put this, then this, and then at the end they put 1, and they calculate it. Then 2, then 3, then 4, and go and so on and on and on, until they find that number, that if you put it at the end of the input, you will get an output with, let's say, 15 or 18 or 20 zeros at the beginning, whatever is necessary. To make you understand how difficult this is to find the right number, I will show you one example that I made myself. So I decided to try to find the number that if you put it at the end, if you add it at the end of hello world, it will give you 4 zeros, only 4, at the beginning. So I went to the same website as before and they put hello world 0. So I didn't get 4 zeros, so I went on. Hello world 1. Then when I reached hello world 3, I got 1 0. Went on and on and on and on until hello world 67. I got 2 zeros. Then on and on and on and on and on until finally at hello world 4250, I got 4 zeros at the beginning of the output. As you can see here, as the number of times you have to try to find a number, it grows exponentially as the number of zeros required grows. Here you can see I do it, and here you can see a real number of a real miner that had to try about 5 billion times before he found that number that could allow him to win the race. And here you can see a little bit why miners are called this way. Because it's a little bit like real miners, that when they go to mine, when they start mining, they don't know if they will find some precious metal or something. Just mine and working until they find something. Well, the miners in Bitcoin also, they just have to go trying until they might, and this is just luck, and until they find that number that allows them to win the race. Obviously, the miners want to win the race because all the bitcoins that they receive are valuable. So miners try to invest to get more computers that are more powerful and more all the time. But obviously, if there will be more computers, they will need less time to create a new block. So how is it possible that it's always 10 minutes approximately? Well, this is because every 2 weeks approximately, the software of Bitcoin changes the difficulty of the math problem so that it always keeps about 10 minutes approximately that the miners take to create the block. How do they do this? How did the software do this? Well, it's very easy. They just change the number of zeros required at the beginning. But you will also be asking yourself, why a new block has to be created every 10 minutes? Why not more or why not less? Well, this is necessary because it defines the monetary policy of Bitcoin. At the beginning, in 2009, every time a miner created a block, he received 50 Bitcoins. This number is halved every 4 years. So, in 2013, miners started to receive 25 Bitcoins per block. Now, in 2018, in the era, we could say, of 12.5 Bitcoins per block. By now, we have issued about 17 million Bitcoins. The total number will be 21 millions. Not one more, not one less. And even though by 2029 we will have already issued about 97% of all Bitcoins, the miners will go on mining until 2141. And little parenthesis, if $1 or €1 or whatever can be divided in 100 parts, Bitcoin can be divided in 100 million parts. 100 millionth of Bitcoin is called Satoshi, in honor of its creator. So, by 2141, the last Satoshi will be issued. From that moment on, miners, the only reward that we will get will be the fees of the transactions. And here you can see a little bit why miners are closed this way. Another reason. Because the monetary policy of Bitcoins, we could say that copies the progressive mining scarcity of gold. Because Bitcoin, for the first time in the history of internet, is a scarce thing. There will be 21 million. And that will be the end. And this is a really, really incredible thing. Because the production of Bitcoin is completely inelastic, and it's not possible for it to adapt to the demand. I suppose you will have asked yourself how to get Bitcoins. Well, if you got to get Bitcoins, you have two ways. Or you become a miner, but by now it's nearly impossible to win the race unless you buy thousands of computers. Or you go to an exchange. Exchanges are usually websites where you can buy and sell Bitcoins for any other currency you want. And some of them, you can exchange it even for other cryptocurrencies. But when you've bought Bitcoins, where do you put them? Well, you put them into wallets, into digital wallets. Obviously, in wallets, they must be kept sure. They must be protected because it's where your Bitcoins are kept. Well, to protect wallets, Satoshi Nakamoto used asymmetric cryptography. He didn't invent it himself, but he was really intelligent to use it in this case. You will see it a moment later. Also, all the wallets of Bitcoin have an address that can be considered that in banks, in a bank account, you have the IBAN code. Well, in Bitcoin, you have your address, your Bitcoin wallet address. The asymmetric cryptography works because everyone has got two keys, a public key and a private key. These two keys are tied together mathematically. Your public key, it's public and anyone can know it and you can show it to everyone because it's also your address. People need it to know where to send to you their bitcoins. Instead, the private key, you must keep it secret 100% all the time, because it's a kind of password that allows you to use your bitcoins. Here below you can see an example of public key and private key. And the best thing of all is that you can create a private key and a public key in like less than 10 seconds in websites, for example, as bitaddress.org. So in 10 seconds you can just create them, and when you've created them, you can automatically, immediately have access to a Bitcoin wallet. And this, I think it's a really important thing, because if you think about banks, to create a bank account, you need a lot of time. You need to say, a lot of private information. In Bitcoin, it's not like this. Also, in banks, sometimes you must even pay money. In Bitcoin, it's just free. So, how does it work, a Bitcoin transaction? A Bitcoin transaction is when you send Bitcoins from one public key, so from one address, from one wallet, to another public key. For the transactions to be valid, you must sign it. To sign one transactions, you have to create a signature using your private key. And then miners, that are the ones that have to validate the transaction, just by seeing your signature and your public key, can know that you used your private key without seeing it. And this is really important, because if you think about it, banks know your password. When you sign a transaction, you put in your password and they compare it. Okay, yes, it's the same. It's him. But instead, in Bitcoin, it's trustless. No one must never know your private key. Using this system, Satoshi Nakamoto allowed miners to validate the transaction, so they can know that you used your private key, but without seeing it. An example that quite helped me to understand asymmetric cryptography is by comparing it with Coca-Cola. What do I mean? Well, everyone knows your public key in Bitcoin, but also in Coca-Cola, everyone knows its ingredients. With the Coca-Cola, when you drink it, you can taste it, you can see, and the Coca-Cola, you can understand it's Coca-Cola. But even if you can taste it, you can see the ingredients, you cannot understand what is the secret recipe. With Bitcoin, it's quite similar. Even if everyone knows your public key and everyone can see your signature, it's impossible to find your private key. Let's put an example of a transaction. Imagine that I wouldn't put but I would put my public key, want to send 1 Bitcoin, that is the amount, the quantity, to Bob. Obviously, wouldn't put Bob, but I would put his public key. For the transaction to be valid, I would have to sign it. I would have to create a signature using my private key. Here below you can see an example of signature. And just by seeing this message, miners can know that I send a message, because they can, as I said before, by seeing my signature and my public key, to understand that they had my password, my private key. They can also see that the message wasn't modified through some calculus, and also they can know that I have the Bitcoin that I want to send. How do they do this? Well, they go to the blockchain and look for all the transactions that contain this public key. When they have found all of them, they calculate them, they calculate the balance, and if I've got 1 Bitcoin or more, they allow the transaction. So we can say that the moment of transaction will be validated. Another part of the transaction, but that it is less important, is the fee. The fee, differently from like in banks, in Bitcoin, it's voluntary. Then you would say, then why do you give them the fee? Why didn't you do this gratis? Free. Well, because miners have a lot of transactions. They receive a lot of transactions, and usually they give priority to the ones that have fee. So, if a transaction doesn't have any fee, probably it will be put into the blockchain, but it will take much more time. Well, we've reached a point where approximately we've seen all the main points of Bitcoin. So here I will resume them in one slide and we will comment them together. Bitcoin is a digital cash that is decentralized and peer-to-peer, that doesn't need a trusted third party, that is not backed by any country, that its access is free, as we saw before. You can go to some websites and create a private key and a public key in really a short amount of time. It's censorship resistant, as we saw before with BitTorrent. Bitcoin is impossible to stop, because if someone wanted to stop Bitcoin, would have to shut down thousands and thousands of computers all around the world. Bitcoin is borderless. It's completely the same if you send Bitcoins to someone that lives in your same palace, that if you send them to someone living to another part of the world. Bitcoin is secure. With asymmetric cryptography, as we saw before, it's really, really secure. And it is for everyone, everywhere. Now that we have seen what is Bitcoin, let's try to compare it with the other, we could say, normal currencies. But to do this, before we should understand what's money, what's the other currencies. Because it's really important that we understand them before we compare them. Nowadays we use fiat money. This expression comes from Latin, and basically it means that fiat money is money that doesn't have any real value. It's money that has value only because we decide that it has value. Before, hundreds of years ago, every country had a gold reserve that guaranteed the value of its bills. But in the last century, currencies started to issue bills that weren't guaranteed anymore. The last country to stop guaranteeing its bills was the US in 1972. From that moment on, the economy of the world has been based on fiat money. Now that basically, it was really fast, but we understood a bit what's our currencies, what's our money, let's try to compare them with Bitcoin. And we'll use as an example the euro. By doing this, we will try to imagine that an alien comes to the Earth, and that from one side we'll have to explain him fiat money, more specifically the euro, and on the other one we have to explain him the Bitcoin. It will be quite a provocative comparison, but it will be useful to see and remark the differences between the euro and Bitcoin. At the end, you will tell me what you think the alien will believe will be the best money. Okay, we'll start talking about the euro, and we'll explain the alien that it doesn't have any real value because it's fiat money. But in the truth, the euro has a social contract behind it. People accept it, and also it has a legal tender. This means that people must accept it, at least inside the European Union. Bitcoin, on the other hand, hasn't got any real value too. It just beats on computers. Well, we could defend this by saying that Bitcoin, as we'll see later on, could become a new digital gold, and that will be the first cryptocurrency that will be decentralized and transferable but not duplicable. But still, I would put this moment 1-0 for the euro. Then we will explain the alien that all the security of the euro, well, at least the cash version of it, it's based on paper ink security. Special paper, special ink, but paper and ink. Instead, all the security of Bitcoin is based on cryptography and math. At least, in my opinion, much more secure. So this point, I will give it in favor of Bitcoin. Then we'll explain that in Frankfurt there is the Central European Bank that with its decisions it can change the value of the euro. Instead, in Bitcoin it's governed by a software that it is unchangeable and it has a monetary policy. It's also unchangeable and fixed. Then we will also explain to the alien that the Central European Bank could and is issuing billions of euros every month to help to grow the economy. Yes, but this is making the price of the euro go down. Instead, as I said before, Bitcoin has a monetary policy that is already fixed and it cannot be changed, and it has a deterministic supply. This means that the total supply of Bitcoin will be 21 million, not one more, not one less. So, at least in my opinions, these 2 points I will give them in favor of Bitcoin. In my opinion, the alien would think Bitcoin would be a better money. I suppose that at least at some point of this presentation, you have asked yourself how much a Bitcoin costs. Well, in this moment, a Bitcoin costs about $6,500. As you can see in this graph that starts at 2013, the Bitcoin price remained similar until about the beginning of 2017, when it started to grow. And it reached a maximum point of nearly $20,000 in December of 2017. Then the price collapsed, and at this moment it just have done some up and down, but it plus or minus remained in medium at 6,500. We don't know specifically what are the reasons for this growth and for this up and down, but at least most people believe that it was just due to speculation. But in the truth, I have tried to convince you throughout all the presentation that Bitcoin is a good type of money. But in the truth, it's not really a good type of money. Why? Well, because it has many problems. For example, first of all, volatility. Money is used to put a value to things. So if a currency has a lot of volatility, it's not useful anymore, because just imagine to have a ruler that one day it's long like this, next day like this, and next day like this. It's really complicated. So imagine that you have a shop and you put the prices in Bitcoin and you have to change the prices all the time. Another problem of Bitcoin is that it's slow. A transaction in Bitcoin to make sure that it enters a block, you must wait at least 10 minutes. And to be sure 100% that all the nodes have received and accepted your transaction, you must wait at least 1 hour. Just imagine that you go to a coffee shop, you buy a coffee, you pay it with Bitcoins, and you must wait like 1 hour to see if the person in the shop has received or hasn't your Bitcoins. Another problem of Bitcoin is that for small transactions, it is quite expensive. The same example as before. If you buy a coffee that costs €1, but you have to pay as a fee another euro, just to make sure that your transaction will not take days to reach the destination, the receiver. So in this case, it wasn't really useful. Another problem with Bitcoin is the scalability. Bitcoin maximum size of a block is about 4,000 transactions. A block cannot contain more than 4,000 transactions. So, if in 10 minutes there are submitted more than 10,000 transactions, they start to accumulate. And this obviously is not good. Bitcoin seems like very private, but in the truth, if you know the public key of someone, you can see at any moment all the Bitcoins that he or she has, and all the transactions that he or she makes. So in this case, it's not really private. It's not really anonymous. However, you should understand that Even if Bitcoin has a lot of problems, there is a community of developers that is working and trying to solve them. So, for example, things like scalability and fees have already improved a lot. And also, you must understand that Bitcoin is only 10 years old. It has a lot of time to improve. On the other hand, there are also a lot of programmers that were inspired in Bitcoin and try to make their own cryptocurrencies. And they too try to improve Bitcoins in many ways. However, at least in this moment, for many people, Bitcoin isn't a currency. It's more like a digital gold. Let's see why. Well, let's try to compare gold and Bitcoin. Gold is scarce. Well, Bitcoin, for the first time ever in the internet, is scarce too. Gold, its adoption was not centrally planned. Civilizations that were separated by thousands of kilometers chose gold as the first type of money. Well, Bitcoin too, until now, has been the best form of cryptocurrency. Gold has triggered all the financial systems that we have nowadays. Well, Bitcoin too is triggering new monetary systems based on new cryptocurrencies. Gold has been surpassed by other forms of money with more successful. But even though it has been surpassed, it hasn't become obsolete. Well, Bitcoin too, probably it will be surpassed by some other cryptocurrency with more success, but it will probably not become obsolete. However, you must understand that there are some differences. The most important one, I would say, is that gold is fungible, but Bitcoin is not fungible. What is fungibility? Well, fungibility is the property of a commodity to make it interchangeable. So, for example, a kilo of gold will be exactly the same as another kilo of gold. Instead, with a Bitcoin, you can track it, you can know where it came from. And for example, someone could not accept a Bitcoin that was used for money laundering. So it also has some differences. But at least at this moment, probably Bitcoin could be considered more like a digital gold. For all the presentation, for all the video, I've talked about the altcoins, for these alternative coins. But what are they? Well, here you can see a list of the top 10 cryptocurrencies in order of market cap. Market cap, you get it by multiplying the price by the supply. These are only the top 10. There are about 2,000 cryptocurrencies in total. But most of them, they are frauds. They were just things that try to steal money. So just be careful if you want to invest. Make sure that you invest in something that has some real properties. However, let's list this top 10. Top 2 is Ethereum. Ethereum is special because it has a really important thing that is called smart contracts. They have, you can do many things with smart contracts, but at least in my opinion, the most important one is that you can incorporate a real contract into a transaction. So, for example, if you buy a house, then you can, with Ethereum, obviously, then you can also put into that transaction a contract, a real contract. And from that moment on, that contract will be public and will be kept forever on the blockchain of Ethereum. So lots of things like the catast or notaries or things like this might not be more necessary in the future. Top 3 and top 5, XRP and EOS, are some some currencies. I don't really like them because they are controlled by some banks, we could say, that can issue all the ones that they want at any moment. So really, it's not like in Bitcoin that is decentralized. These currencies are centralized mostly. Top 4, Bitcoin Cash, and top 7, Litecoin, were both currencies that tried to improve Bitcoins in things like scalability and fees. However, they didn't have as much success as Bitcoin because all the Bitcoin users know that scalability and things like this, they will improve in the future. So they're still used, but not as much as Bitcoin. Top 6, Stellar, its aim primarily was to give banking to people that couldn't have it. So, for example, in countries like in Africa and Asia, it's really difficult to have a bank account. So Stellar wanted to give them this opportunity to save their savings in virtual currencies. Another interesting thing about Stellar is that its total number grows of 1% every year, so there is inflation. Also, Stellar was created by a no-profit company. Top 8, Tether, is maybe the most different money to all the others because it's the only one that is not volatile. Why? Well, because a Tether always costs $1. Because there is a company behind it that for every Tether that has put into circulation, it keeps a US dollar. And also Tether it's really used for commercing between cryptocurrencies. So it's like used as a dollar but without using real dollars, just by staying into the cryptocurrency world. As you can see here, its volume it's really big. It's like if all its market cap, all the Tethers were sold and bought on the same day. Instead, you can see that the volume of Bitcoin is higher, but it's only a little part of the total market cap. Top 9, Cardano. It's like, we could say, a copy of Ethereum, just like Bitcoin Cash and Litecoin is for Bitcoin. Some people say, most people say that it improves some aspects of Ethereum, but well, it's just, we don't know, we just have to see if it will really improve or not. And top 10, Monero, it's different from the others because it improves aspects like privacy. Monero is much more anonymous than Bitcoin. Well, for doing this presentation, I obviously used many things from many websites, mainly videos on YouTube. I wanted to thank the professor Ferdinando Ametrano. He was an Italian professor and he did some really useful videos that helped me a lot to make this video. And here, well, you can see some other things, you will find them in the description. Thank you a lot for your attention. If you like this video, put a like, and if you would want to see more of this type of videos, just subscribe to my channel. Goodbye. Ferma. In many places. Anita, per favore, basta! Mi continuavi a far muoverti, sconcentravi un casino. Vai via, per favore. Everything started the 31 of October. Now I'll put you an example. I went into merda. Stop. Già ho fatto. To send them. No. It's also a good way of seeing other things. Non riesco più a cambiare slide. Non riesco più a cambiare slide. Sono messa tipo 5 volte. Quello lì per quelli alla fine.